Hello everyone and welcome to a new discussion in the series of groundwater exploration. This is the 12th part. Before in part 10 and part 11, we have discussed different geophysical techniques starting from electrical resistivity and in different types of electrical resistivity methods even up to tomography. And then we have discussed in part 11 about seismic methods, gravity methods, electromagnetic methods, etc. Whatever the required understanding from groundwater engineering point of view have been discussed, but these subjects, these are altogether they are separate subjects, full length subjects are there, but the aim of this course is not to teach or not to discuss complete geophysics part, but relevant to groundwater exploration. Now, once geological investigations have been done and one or many geophysical methods have been adopted, then finally we are having some idea about the groundwater, availability of groundwater, extent of aquifers and depth and water table and all that kind of information, some preliminary information might be there. So, now the next step can be the drilling, test drilling or final drilling also. So, this that is involves the exploratory drilling, which we have also discussed exploratory drilling when we have been discussing about electrical tomography, electrical resistivity tomography, and there also some exploratory drilling is done and then test drilling is also done and final drilling can also involve, can also implied the same way. Now, geological and geophysical surveys as just mentioned sometimes are not adequate sufficient to get the complete subsurface hydrogeological conditions of an area. In that case, we go for exploratory drilling. So, even if surveys indicate the presence of aquifers, but how much yield would be there, what is going to be the productivity and quality of water, that is also to be evaluated, assessed, and that is done through the exploratory drilling. When basically when drilling is done, we know that at what speed drill machine is going or bit is going and also what kind of rocks it is bringing through cuttings and what kind of quality of water it is bringing. So, all kind of information, plus you would also get information about the depth of water table or thickness of aquifer. So, aquifer and reservoir dimensions, their boundaries, lithophases means how different lithologies are there, variations, structures, some geological formations, geological structures, structures of different rocks formations are can also be investigated through these exploratory drilling and at a regional scale for further development of groundwater in a planned manner. That is what it is done. So, for suppose the industry has to come which require lot of water, for which they can afford all kind of geo exploration methods or groundwater exploration methods, in which they can also go for exploratory drilling to make sure that the amount of water which is required, the volume of water which is required on regular basis is available or not. So, such kind of informations about the dimension and boundaries. The word reservoir is used here, but it is this same terminology is also used in case of oil industry. In that case, in oil industry and in groundwater scenario, reservoir does not mean that you are having a underground huge tank. No, reservoir means it is a aquifer with saturation with which is having water. If it is confined aquifer, then we can also call sometimes in loose sense is a reservoir of water. So, it is therefore, it is necessary to know lithological and sometimes hydrological variations by doing this exploratory drilling or by excavating a hole by drilling methods and acquire characteristics, formations characteristics, acquire information about salinity and then once the water becomes available, that can be also tested, or there are some well logging methods also by which salinity can also be tested. So, now we will be looking different types of drilling methods which are known and main drilling method. There are many depending on type of rocks or formations, different drilling methods are adopted. So, very simple method, many times you might have seen in Indo-Gangetic plain if you are, or in some alluvial areas, they do not have any machine or motor on the top of this. They are having just this auger, and with the human resource they just keep moving and go to certain depth and take out the whatever the sediments it has excavated on the surface, and then again add a length through a pipe and then go again and do it manually. So, that kind of manual methods also exist, but these are more modern methods which we are going to discuss. So, shallow holes, shallow means not too deep, maybe 5 meter or maximum maybe say we can say 10 meter, but it is a relative term. Shallow holes down to a few meters can be dug or excavated by hard or power augers. This is power auger, but hand auger are also there, or boring equipment, some other equipments can also be employed. But in Indo-Gangetic plain, the hand auger is the most common cost effective thing, and in a day or two they can provide you sufficient bore hole with of course hitting the water table as well. So, they say commonly however power drills of various types are used for deep exploration for groundwater. So, the various types will be employed depending on the what kind of rocks are present. So, these those who do this they are professional drillers. If you call them for certain area, they would be having some idea about the rocks present in that area, and then they will suggest the appropriate drilling method which they are going to adopt. So, a drilling is costly operation, we know. Manual drilling may not be as costly, but when we are going in a hard rock terrain, there it is important that it is costly operation, costly affair, and therefore, the drilling program should be aiming to obtain the maximum subsurface information and with a number of minimum number of holes, because it is a completely luxury kind of thing. You cannot go and have a 10 bore holes in an area, in a small area. Since it is a costly affair, costly operation, and therefore, the site which is chosen for first drill has to be very much explored by remaining earlier methods, and then when this operation is being done, then the maximum subsurface information should be obtained, because otherwise it will cost lot. So, whatever the material it is bringing, that should be properly logged, should be kept, and what kind of small pieces of rocks, or if mud is being used, water is being used, all that information and the speed the way drill machine is going on, everything has to be noted. That is what meaning here is the maximum surface information. Now, selection of a type of rig suitable for formations, again it will depend on geology which is present there, likely to be penetrated needs sound geological advice. That means first extensive geological information should be collected. If it is possible, a cross section, geological cross section should be made. Then starting from these geophysical methods can be adopted, and then only this costly affair should be resorted. So, sound geological information is very much required, and to choose a type of rig or type of drilling which would be adopted for a certain area. Terrain characteristics and approachability, because machine will be going there. So, in hilly regions it is a challenge, but in plain areas it might not be challenge. So, terrain characteristics and approachability may be deciding factor on the deployment of a rig or deployment of a particular type of drilling rig. That will depend. A drilling technique might be suitable for certain kind of area, but if the terrain is highly rugged and approachability is not there, then probably that cannot be done. So, there are certain drilling methods, and many more are coming, many variants of these drilling methods are coming, but basic kind of drilling methods which we are going to discuss, that is the methods of drilling. So, drilling methods suitable for various geological formations and their advantages and disadvantages are shown here. So, the one method is called very simple method, it is more or less a manual method, which is cable tool. So, through a pipe a tool is dropped there. So, this is good for the materials which are unconsolidated, and some hard formations like clay or clay things are there. Like for example, I would say in endogantic plain this is the most suitable. Now, usual maximum depth you can achieve is about 600 meter, which is too deep anyway. Then water table depth which is suited in this one in any depth basically when you are having unconsolidated sediments. Approximate rate of drilling per minutes per day that can be even 1 to 30 meter. As I have said also that in endogantic plain using this manual auger they can sometimes create a bore well and install a pump in just 2 days time or even 1 day time, depending what depth you are or at what depth the water table is there in that particular area. Now, hydrological conditions, hydrogeological conditions that create problems during such type of cable tool drilling is the drilling rate slow in the boulders, clay and quicksand. So, in subsurface if there are these problems, then there might be some problem also. And the diameter which is achieved through for the bore well is through this cable tool method is between 8 to 75 centimeter. So, which is again quite good, and then submersible pumps or otherwise things can be installed quite easily. Now, advantages and disadvantages, most of the points which I have discussed are either conditions or advantages. That so the most versatile and this technique cable tool is most versatile for a wide range of conditions, and slow rate of drilling because more or less it is manual, has to be cased and casing retrieved. Why it has to be cased? Because you are having unconsolidated material that the well should not collapse, and therefore, from the top you require the casing, a pipe. So, chances of losing casing is high in deep holes. Samples representative only when deepening is done by the baling. And information on quality of water can be obtained during drilling, and a baler test possible. Water levels can be measured. So, it is a quite simple, quite common method, quite cost effective method in case of unconsolidated sediment, example of endogantic plain or some other alluvial areas. Another type of drilling method is direct circulation rotary, that rotates, keep rotating that bit and in front of this rotary instrument, and then of course, it is a motor driven or compressor driven. So, this kind of technique is suitable for formations which are having clay, silt, sand, gravel less than 2 centimeters, soft to semi consolidated rocks. So, in the first example in cable tool unconsolidated mostly, but here we are saying some hard rock, some semi consolidated rock. The depth which we can achieve 450 meter, which is quite good. Any depth water table can be there, and approximate rate of drilling is 100 to 200 meter because motor is there, power is there. Drilling rate slow because of sticky clay layers or hard pans or caving cans and other reasons also. In case of high artesian pressures need to be controlled by thick mud when mud is being sent in this to retrieve the rocks which is cutting or the material which is cutting. So, casing needed really, and in such cases because the rocks are semi consolidated. So, you do not require casing. So, that cost will you are going to save, and the samples are contaminated with drilling and cannot drill through carbonaceous formations without casing or sealing or in hard rocks. So, that is the disadvantage in the last part. Now, next one is the reverse circulatory drilling. So, it is a direct, first a previous one was the direct circulatory drilling, now it is reverse. Again clay, silt, gravel, sand, cobble, that kind of sediments there, 150 meter, and any depth between. So, depth is now getting less because that much is only required, and 100 to 200 meter per day can be obtained. And the other hydrogeological conditions are same as in case of direct circulatory, and then the usual diameter range is between 40 to 150 centimeter, and most rapid in soft rocks. And this reverse circulation rotary casing needed rarely because the rocks are consolidated or coarse grain, cannot drill through hard rocks. So, this method is not suitable for hard rocks, and cavernous zones here, that means when you are having openings in subsurface conditions, and if water is used, difficult to contain artesian pressures. So, that is because in such cases you cannot retrieve the cutting materials, which is this method is doing. Now, further there is a drilling method which is called air rotary, in which not water is used and just air through compressor is sent. So, this method is good for hard rock terrain, makes a lot of noise also, because it is cutting the hard rocks like granite, basalt, schist, consolidated sandstone, shale, etc., where fractures contribute water. These are consolidated rocks, so chances of getting water only in weathered zone and fracture zone. The depth it can go for 30 meter, or a water table can be found in such cases in any depth, and it is 10 to 60 in case of apparent rate of drilling meter per day, and it is because it is basically making a hole in a hard rock terrain or hard rocks, therefore, it is slow, and it may be in range of 10 to 20 meter per day. And if there are problems with the caving and clays, of course, it is hard rock, so no casing is required except in overburden or up to caving zones. So, top part which is weathered fractured, in only in that part the casing might be required. Drilling that limited to first high yielding zone, because there is no use of going deeper and deeper. That is why here the depth is only 10 to 60 meter, because in consolidated section or part after below this underlying this your weathered and fractured part, it will not have water. So, why to go deeper and deeper? This point earlier in some other videos I have discussed. So, drilling depth limited to the first high yielding zone depending on the lifting capacity of compressor, because after all whatever the instruments which are going, it has to be whatever the depth, then the material which is being drilled or cut has to come on the top. So, it will depend on the compression strength also. Yield of wells limited by its diameter. Sometimes a larger diameter well can give good yield, but not the time it is necessary, not all the time it is necessary, depending on the basically groundwater conditions. So, I would show you the air rotary drilling rig would look like this, very modern one. It would look like this. There is compressor and all driven, there is a driver chamber. So, he can do all these things and it can move forward, backward in all sides, and likewise. A cable tool percussion drilling rig is something like this, which drops this tool and keep boring, but it is in consolidated, whereas this bit will work in hard rock terrain. So, the popular method of drilling are air rotary, cable tool, both are shown here. These methods use mechanically powered drilling rigs. So, the equipment, the drilling rig equipment itself is sufficient for making such holes there. So, first we will go little detail in the air rotary drilling rig. In this method, the down the hole hammer drilling system are air rotary method, and down the hole hammer in which it is dropped cable tool kind of method. Drilling systems are similar in design and function, with the main difference being the ladder system having the additional cutting action of air driven hammer. So, here this air rotary methods are more efficient, can do the drilling for a larger hole at a high speed. Now, fully cased drilling with rotary drive is done like here, that at the end of what you are on the right side, it is saying that extract the casing with rotary drive during concreting. So, that is the final stage of that one. So, initially the drilling will start from here, it goes deeper with all these drilling bit is moving ahead, and then casing starts. So, install reinforcement case with ancillary winch, drill and this thing, and finally pour concrete if it is required depending on this formations, and then finally the casing is extracted, and the drive is also, the rotary drive is extracted, bell is there. Now, a pump has to be start or installed. To prevent caving, a casing pipe is driven as the hole is deepened, because there sometimes the there might be caves, small caves or a hole or a gap, and that if it is there, it may create a collapse kind of situation of a well, and therefore, to that depth the casing is very much required. This is assessed during the drilling by the driller or experts by themselves. They, by the sound of drill machine or equipment and the way, the speed in which it is going and the cutting material which it will be bringing, they will assess that they have found some cave there, and accordingly the decision has to be done at that location. So, drilling cuttings, the material which comes up are periodically bailed out by a bailer. That means, it is collected and put in a sequence, so that we know that at what depth what kind of rocks or formations were found. In this rotary drilling, the casing pipes are extracted in consolidated rocks, like here if rocks are there, and where the formations are unconsolidated, then or semi unconsolidated, natural or gravel pack wells will be constructed and the casing pipe pulled out. So, in the surroundings this pack is fed basically. So, and once that is settled down, then the pipe is taken out and then well will be maintained for a long time. Because why the cable end? So, that will allow the flow of water towards the well. So, we cannot put fine material, we have to put materials like which is gravel pack, we say gravel pack wells. So, a large sediments much bigger than your sand. Drilling hydraulically bar rotary drilling rig is there, little instead of a typical air rotary drilling, here is some auger part is also added here. So, in rotary drilling there are mainly two types of rotary drilling methods, one is hydraulic rotary drilling, another one is air rotary. So, in which one is hydraulic one, water is also used, and in air rotary water is not used. Hydraulic drilling or rotary in which materials are excavated by the rotatory action of drill bits of various designs, for example, fishtail, rock roller and others, attached at the bottom of your this string of drill pipes and a stabilizer collar and to the kelly at the top. So, it is the kelly, it is the top. Now, the kelly provides the rotatory motion required to loosen and break up the material by bit. So, by which this action of kelly and basically in subsurface the material is broken, and then further and further keep doing till you reach the desired depth. So, in this drilling cuttings are brought up to the surface by water, because hydraulic drilling is there, sometimes with the clay additive like bentonite circulating through the drill string and attachments and annular space outside. So, sometimes water, sometimes bentonite or a special kind of muds are put, so that whatever is being cut is brought out on the surface, and that is cleaned and kept for reference purpose, and to understand the entire subsurface arrangement of rocks. On surface you get the lithologs basically. So, clay additives are added, that means the mud, clay additives are added to water to maintain the viscosity, to bring up the coarser drilling cutting materials or rock pieces, and to plaster the whole wall, prevent caving and control artesian pressure. So, this mud which is put through in this drilling, hydraulic rotary drilling, does two kind of services. One, it helps to bring the coarser drilling cutting material on the surface, and also if there are some chances of caving or other artesian pressures, then it will shield those area because of its a fine material. So, there are it is also rotary drilling is also called down the hole hammer drilling, in which is air rotary drilling rig. A little different type is shown here, and that compressed air serves as drilling fluid to lift the cuttings. So, here the compressor air is going at a very high velocity. The air compressor or air hammer drill consists primarily of a pneumatic hammer for delivering continuous impact of drilling bit, so that drilling bits keep moving, and this and a compressor for supplying compressed air to the hammer unit. And this the air which is sent through this compressor for running the drill bit also brings the material on the surface also. So, drill bit breaks up and pulverize the rocks. It makes generally the powder of the rock. Pulverize here means is combined by rotatory and percussion actions. That means it also hits hammer kind of thing and rotary kind of thing, combined actions. So, in this down the hole hammer DTH or rotary drilling, in the method as well as cable tool method, water samples can be collected and water levels can be measured. After all, why we are doing all this? To know what is the at what depth the water is available, and if water is available, then we can also assess the quality of water would be available, and you also may get the quantity of water. If it is there, a pump is installed, or maybe artesian conditions as well. So, in this down the hole hammer DTH method, the discharge can be observed during drilling as well. So, how much water it will yield, that kind of assessment can also be done during the drilling itself. So, in that way it is a quite good method in which you do not require much water, it is a air rotatory, because sometimes for looking water you are requiring water and water is not available, that is the problem. So, therefore, this air rotatory drilling methods are becoming more popular in the areas where water is a problem. So, slug test or baler test can be performed during rest periods in drilling. So, the basically in the down the hole drilling method, or this we say DTH also, in this method basically the difference between air rotatory system and this drilling system are primarily the cutting action which is being taken by these drill bits, and whatever the resulting cuttings that is there. So, one method will pulverize, means make powder of that material. So, the assessing the what kind of subsurface formations are there becomes little difficult. But if we through this method of drilling which we get the larger pieces of rocks, then it is better. So, depending on what kind of situation of groundwater conditions are there, accordingly we choose the different method. In this down the hole hammer method, which is uses the rotatory percussor action cutting through the use of bottom bit, which is, as you see, the bit is completely different, and this pulverized also. So, the recovery of cutting material becomes little difficult, and whatever is coming may not we easily assess what is the situation. So, in this percussion drilling, in some literature you may also find the word percussion drilling is one of the oldest and most versatile and simplest of drilling methods, because you do not require much compressors or that thing. Through this arrangement of cable, you just keep dropping, lift again, fit, drop like this, and drill is made or the hole is made. The drilling is done by lifting and dropping of a string of tools suspended on a cable through this a small rig, that can be done. Manual methods are also adopted in many parts I have seen in Indo-Gangetic plain, where they do this manual method rather than involving a machine. They just keep having this cable tool method and drop it. So, as we have seen, the bit is attached at the bottom of the tool string strikes and crushes the rocks at the bottom of the hole. But as when we were comparing, we have seen that good for the soft rocks, but for in case of hard rocks, these methods, dropping a cable tool or a cable tool method may not be very good, will not achieve fast results basically, and may be very time consuming also. You know, the differences between air rotatory system and down the hole systems are primarily the cutting action. Down the hole hammer uses a rotary percussor cutting action through the use of the bottom bit. Now, other popular methods of drilling are also there, and some variants of basic kind of drilling methods are also coming, or machines are also coming, like bucket auger drilling method is there, in which the bucket is used primarily on unconsolidated material. So, for unconsolidated material, the drilling is anyway is very cost effective, not very costly, and secondly lot of methods can be employed. But in case of hard rock terrain, only few types of methods can be employed. That is the major difference here. And this bucket auger drilling method is good for if we are going for large diameter boreholes construction, ranging from 24-inch to 48-inch, big hole. But it is only possible in case of unconsolidated material like Indo-Gangetic plain. And interestingly, this is just related with this, sometimes when large holes are made of 24-inch or up to 48-inch, big hole sometimes after the drilling is left, and a child playing nearby goes inside the bore well, and then we have been seeing on television what kind of problem comes. And in western UP or in other parts of Indo-Gangetic plain where we are having a unconsolidated material, such incidences keep happening almost every year, few times in a year. That is very bad, but anyway, generally too much large holes are not required. Instead of one large hole, two holes of optimum size would might yield better results. So, reverse circulation drilling method after this bucket auger drilling method is there. In reverse circulation drilling method is quite unlike any of our other systems which is profiled in that is a very large rig requiring a rig footprint of both the rig itself as well as the machine dug settling pit. Now, if accessibility is not there, and if see what kind of arrangements would be required, that is very large rig would be requiring for this reverse circulation drilling method. Now, there is another type of drilling method which is mud rotary drilling method is there, where mud rotary bell drilling method is considered a closed loop system, assuming that there will not be any loss to the mud, and that is the mud is cleaned, it is cutting. So, whenever the cuttings are coming, it is removed from the mud and then is recirculated back down the borehole. So, in that way also it is done. So, now finally we are ending this discussion by just recapping these things, that rotatory drilling is the most common drilling method in both water and geothermal well drilling. It is not a common thing in India, but of course, it is a very common thing in case of water in India, that rotary drilling is the most common method. Though there are, we have seen several variations in the rotary drilling, reverse rotary drilling and others. So, each having their advantages and disadvantages. This you have to remember that no technique is universal. For different areas, different techniques should be employed. If I am having just one type of rig and I keep trying to make holes in everywhere, I am not going to have cost effective results. So, depending on the area, depending on the subsurface geological condition, depending on the requirements of water, the yield, appropriate technique should be adopted. So, with this I end this discussion. Thank you very much.